All right, mathematicians, this is the video for the fraction checkpoint review. The fraction checkpoint will look just like this. So if you feel good on the homework, you will feel good on the quiz. Number one, Lily says that 7/8 is bigger than 5/6. Do you agree with Lily? Drawing a picture is always a great idea. So I'm going to draw 7/8. So you cut it into fourths with a plus sign. And then you cut each piece in half with an F. And that's a good way to make 8. And I can shade in 7/8. And I need to draw 5/6. So I'm going to draw like a peace sign. And then split each of those in half. And make 6ths. And shade in 5/6. Okay, if your picture is not perfect, it can be hard to tell which one is more. So a good way of thinking about this one might be, I have a tiny little 8th piece left, and I have a bigger 6th piece left, which means this one has more shaded stuff because it has less unshaded stuff, if that makes sense. Okay, if your picture is not quite perfect, it can be hard because these are very similar. But Lily is correct. So I'm going to say yes, I do agree with Lily. Now, if you feel like this is just too much to comprehend, or you feel like your pictures are just too similar, remember this very powerful, important fraction concept. If the denominators are not the same, so I'm looking at my denominators and I see an 8 and a 6, and I'm trying to think, what could I make an 8 into, and what could I make a 6 into? Let's see, I'm giving some multiples of 8. 8, 16, 24, and multiples of 6, 6, 12, 18, 24. You can make them both have a denominator of 24. So 7/8. If you multiply the denominator by 3, that will give you a denominator of 24. But remember, if you multiply the denominator by 3, you better multiply the numerator by 3. Fractions like to be fair, and the last thing we want is our numerator or denominator to get all blubbery and emotional, right? So we need to multiply by 3 over 3, which is like multiplying by 1 whole, and that will give us an equivalent. So 7/8 is the same thing as 21/4. And now I'm going to make 5/6 have a denominator of 24 as well. If you make the denominators the same, it's ridiculously easy to compare them, especially with two fractions that are so close, like these two. So 5/6. To make the 6 into 24, I need to multiply by 4. And if you multiply the denominator by 4, you better multiply the numerator by 4. And we get 20/24. Oh my goodness, look how similar they are. What's bigger, 21/24 or 20/24? 21/24 is bigger, which is why 7/8 is bigger. So again, if your pictures seem too close to call, right, too close to be able to tell, always remember that you can make the denominators the same. If the denominators are not the same, and then it's crazy easy to tell which one is bigger. So 7/8 is bigger. Lily is correct. Lots of fraction concepts in that problem number 1. Number 2, Grace says that 2/4 and 2/3 are equivalent. Grace, do you agree with Grace? No. All right, 2/4 and 2/3. I'm going to use these egg cartons to help me show it, but I'm also going to show another way if the egg cartons are really not your jam, all right? So let's show 2/4. So we have 2/4. That would be this many eggs. And remember, 2/4 is equivalent to a half, right? So that makes sense. And 2/3 of an egg carton, I'd split the egg carton into 3 chunks, and I would shade 2 of those 3 chunks. And I can obviously see right away, Grace, no, they're not equivalent, right? 2/3 is more than 2/4, right? That second picture is bigger. If you don't like the egg cartons, you can always draw a picture, right? I could draw 2/4. And if circles are hard for you, you could always do like a rectangle or a square. And these are different enough that it's easy to tell that 2/3 is bigger, right? I can even put some symbols in there, right? So they are not equivalent. One is definitely bigger than the other. Remember, always, you can do this too. If the denominators are not the same, make them the same, right? 2/4, I could make it have a denominator of 12, and 2/3, I could make it have a denominator of 12. 2/4 would be 6/12. Oh my gosh, and if I look at my egg cartons, I can see 6 out of 12 eggs, right? And 2/3, if I multiply the top by 4 and the bottom by 4, that'd be 8/12. 6/12 and 8/12 are not equivalent, okay? All right, so the answer is no, 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 Grace. Stick with us, Grace. We'll help you along. All right, on to the back. Number 3, write another fraction that is equivalent to 1/4 and 2/3. There are an infinite number of answers that Mrs. Judson would accept. As long as you multiply the numerator and the denominator by the same thing, you will get an equivalent fraction. And remember, the reason that works is if you multiply the top and bottom, for example, by like 2/2, that's like multiplying by 1 whole. And when you multiply by 1 whole, nothing's changing, right? The numbers look different on your eyeballs, but if you were to draw a picture, they're exactly the same amount. You could multiply the top and bottom by 37, I suppose, right? That would work. But you might want to choose numbers that are easy to do in your head. So doubling is very popular. If you double the top and double the bottom, you will get an equivalent fraction. You could triple the top and triple the bottom. You could multiply the top by 4 and the bottom by 4. You could multiply the top by 10 and the bottom by 10. As long as you multiply the top and bottom by the same thing, you're good to go. 2/3, I'm going to multiply the top and bottom by 10 just to show you something different. But you could also just double the top and double the bottom. Okay? As long as you do the same thing to the numerator as you do to the denominator, you will get an equivalent fraction. Fractions like to be fair. Number 4, write the improper fractions as mixed numbers. They're improper because they're more than 1 whole. 3/2, I could take out 2/2, which is the same as 1 whole, and I have 1/2 left. If your brain is feeling a bit fuzzy, drawing pictures or thinking of food is always helpful. I could draw 3/2. 1/2, 2/2, 3/2. And I can see that 3/2 is the same thing as 1/2. 7/4, I could pull out 4/4, which is the same as 1 whole. And I have 3/4 left, right? 4/4 plus another 3/4 is 7/4. Again, if your brain is feeling a little bit fuzzy, thinking food is always helpful. Drawing pictures is always helpful. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. 7/4 is the same as 1 whole and 3 more fourths. Number 5 is the exact opposite. Now let's go from the mixed number to the improper fractions. Check out those denominators. Those are very helpful to look at first. 1 and 1/4, I'm thinking fourths, 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 fourths. I know that 1 whole is 4/4, plus another fourth is 5/4. And again, if your brain is feeling fuzzy, draw a picture. 1 and 1/4. Because it's in fourths, I'm thinking fourths, 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 fourths. There's 1 whole plus 1 more fourth, and that is 1/4, 2/4, 3/4, 4/4, 5/4. 3/2, I know that 2/2 is 1 whole, another 2/2 is another whole, another 2/2 is another whole. That's 6/2 plus 1 more half is 7/2. Even though halves are easy to comprehend, something about this question makes kids say what? So drawing a picture can be really helpful. So 3/2, I'm thinking halves, halves, halves. So there's 3/2, right? 3 wholes and a half. And if I count those halves, I see 1/2, 2/2, 3/2, 4/2, 5/2, 6/2, 7/2. Number 6, add the following fractions. If the denominators are already the same, easy. All you have to do is add the numerators. 1/6 plus 4/6 equals 5/6. And you could draw a picture. Right, there's 1/6 plus 4/6, and altogether 5/6 of the picture is shaded. 1/4 plus 3/8. Oh, not quite as easy, but all we have to do is, if the denominators are not the same, make them the same. And I know if I double the top and double the bottom, 1/4 is equivalent to 2/8. Breathe a sigh of relief. Now the denominators are the same. It's super easy to add. 2/8 plus 3/8 equals 5/8. And again, you could draw a picture, but a lot of you probably don't need to for this one. 2/8. And can you tell that that's 1/4 of the picture, right? Which is the same as 2/8. 2/8 plus another 5/8. I'm sorry, plus another 3/8. I did one too many. 3/8. There it is. And altogether, that's 5/8. Number 7, same thing, but subtract. If the denominators are already the same, breathe a sigh of relief. You just have to subtract the numerators. 4/5 minus 2/5 equals 2/5. And you could draw a picture. Splitting into fifths is a little bit funky. Okay, so you could literally use your eraser and say, here's 4/5, and turn that eraser around, or that pencil around, and use your eraser, minus 2/5, and I can see that 2/5 are left. 1 1/3 minus 2/3. The denominators are already the same, but is your brain going, something about this looks odd, right? And the reason it looks odd is you can't do 1/3 minus 2/3, right? You can't do 1 minus 2. So your job is to make that mixed number into an improper fraction. 1 whole is 3/3 plus another third is 4/3, right? 1 1/3 is the same as 4/3. Now I can subtract. 4/3 minus 2/3 is 2/3. A picture is always, always helpful. I could draw 1 1/3, which was my first number. Right, here's 1 whole plus another third. There's 1 1/3. And I could just take my pencil and turn it around to the eraser. 1 1/3 minus 2/3 minus 1/3 minus 2/3. And I can see that 2/3 are left. Bonus! 1 1/6. 1 1/6 minus 4/12. First things first. There's like a 2-step thing we have to do before we can actually subtract. If the denominators are not the same, so I'm going to change 1 1/6. If I double the top and double the bottom, 1 1/6 is the same as 1 2/12. And then I'm going to subtract 4/12. But I still need to do something. Does it look funky on your brain? It should look a little funky because you can't do 2/12 minus 4/12. So you need to make that first number into an improper fraction. 1 2/12. I'm thinking 12ths, 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 12ths. That 1 whole, right, that's 12/12. Plus another 2/12 is 14/12. Now I can subtract. 14/12 minus 4/12. So for this bonus one, you had to make the denominator. Then you had to make that first number into an improper fraction. Now the subtraction, now it should look easy. 14/12 minus 4/12 is 10/12. And if you want to be super fabulous and simplify, cut the top in half and cut the bottom in half. I would accept 10/12 or 5/6 for a bonus point. All right, here are the answers for the first page of our checkpoint review. And remember that this will look exactly like the quiz. So if you're feeling awesome on the review, you're going to feel awesome on the quiz. All right, kiddos, I will see you in class.